So we're going to take a look at one other method that you can use to find limits when x is approaching infinity or negative infinity down here. So you can't just plug it in using substitution. We need to use this list of rules. The rules are the same type of rules that you learned with rational functions because it's a fraction. So basically, when x is approaching infinity, you're looking at the right and left side of the graph. So it's really approaching the horizontal asymptote. So this is really just a list of rules for the horizontal asymptotes of rational functions. So remember, anytime the denominator is going to blow up and get really big, a function will approach 0. And so it's called the principle of dominance because you're looking for the dominant term. And for polynomials, that's the higher degree. So x squared is higher than a linear function, x cubed is higher than a quadratic function. And so if your degree a, so the numerator, is smaller than the denominator, so the denominator wins, then the limit is always going to be 0. Remember the horizontal asymptote y equals 0. You're looking for the highest degree or power of x. So then what if the powers are equal? So if they are equal in power, then you strip their coefficients. So the horizontal asymptote approaches c over d when x goes to positive infinity or negative infinity. And then this one, the numerator is bigger. So if the numerator is bigger, there's going to be that slant asymptote. So what you need to check is if you're plugging in infinity, plug in a positive number on top and bottom. If you're moving to negative infinity, think about a negative number on top and bottom. So it says check the sign, S-I-G-N, by substituting with a large value of x. So either your answer is going to approach positive or negative infinity. So I'm going to explain what that looks like down below. So here's a set of problems. I'm not going to do all of them. So I'm going to start out doing some of them for you so that you get the idea. There's only 24 problems, and there's a set of answers on this back page. So don't look at them yet. The whole point is to get an understanding of this. And I'm actually going to skip problem 1 for a minute, and you'll see why. So when I look at problem number 2, I'm approaching negative infinity. Where is the power greater? So in this case, x is tied. So we strip the coefficients and the function would approach 4/5 as our y value limit when x goes to the left side of the graph because 4/5 is the horizontal asymptote. All right, in example 3, they again are equal in power. Linear function, we're plugging in infinity. So we'll get 3 billion over 1 billion. And this is actually insignificant over here, these thousands and hundreds. So we strip the coefficients and it would approach 3. So let's look for another example where the powers are equal. So how about example 5? Again, the powers are equal. So I can strip the coefficients and get 5/4. How about example 10? I can strip the coefficients and get 3/4. So you get the idea of stripping the coefficients. So let's look for a different example. And I will come back to number 1. So number 4, we're going to infinity, or we're going to negative infinity. The bigger power is in the denominator, x squared. So this is the rule that the denominator blows up and gets really big. And so if the denominator blows up and gets really big, the function will approach 0. So let's see if we can find another example where the denominator blows up and gets really big. How about example 12? 3x cubed. So cubic function, linear function in the numerator, that's going to blow up and get really big. So anything divided by a really big number is going to approach 0. So let's look at 6, 7, 8, 9, and 11. All of them have a numerator that is bigger in power. So in the past, for rational functions, they would all have slant asymptotes, and we would complete some division. We're going to use this rule. If the numerator is bigger, our limit is either going to be positive or negative infinity. So we're going to think about substituting in a large value of x. I'm plugging in negative, a big negative number. If I plug in a big negative number and I cube it, won't the numerator come out negative? And if I plug in a negative number and square it, won't the denominator come out positive? So what is a negative number divided by a positive number? Negative. So this function will approach negative infinity because negative divided by positive is negative. How about the next example? I'm plugging in positive infinity. So I would get a positive solution divided by a positive solution. Positive divided by a positive. This function will approach positive infinity. So if you want to try 8, 9, and 11 right now, pause the video and try them. Now I'm going to explain them. Number 8, if I plug in negative infinity, this term is going to be a very big positive number. The dominant term will be positive. The denominator will be negative, right? Because it's negative infinity plus 1. Positive divided by a negative will be negative infinity. Let's see, I'm plugging in positive infinity, and a positive divided by a positive will be positive infinity. Number 11, I'm plugging in a positive infinity. A positive divided by a positive will be a positive infinity. So I'd like to go back to example 1. We haven't studied properties of limits. We're not going to have much time to do that this year. So I just want to tell you that if you're taking the limit of 3 different functions, you can do the limit by checking each one separately. So if I was going to plug in infinity to the constant function of 7, I would still get 7 because it's a constant function. If I was going to plug in infinity into 1 over 3x, the denominator blows up and basically makes this 0, so 7 plus 0. And if I was going to plug infinity in over here, I would also blow up and get just 0. So 7 plus 0 plus 0 is 7. So if you have 2 separate fractions, you can evaluate them separately and then just add or subtract them. So I'm going to leave you 13 to 16 to try, but I want to take a look really quick at a couple last problems on the back page, 22 and 23. And then you can try the rest and check your answers and then complete the Google form. It's just a 6-question kind of quick test for understanding. It's not a quiz, but I'm going to be looking that you got them correct to give you credit for today's work. All right, so I'm going to evaluate these 2 parts separately. I'm plugging in infinity. This is a linear function, so half of infinity is still a really big number. And then over in this fraction, the denominator blows up and goes to 0. So this section goes to 0, but this part of the function would go to positive infinity. So overall, 22 would approach positive infinity. And I just want to look at number 23, and then I'll be finished with this video. We haven't talked about how a sine function compares to a linear function. Which one do you think is dominant? The linear or the polynomial function? A sine function will just oscillate between 1 and -1. But if you plug in a really big number, x can go to a really big number. So this is a small number divided by a large denominator again, which will approach 0. And I just want to think about one other example that's not on this page. If you have 2 to the x over x squared, and let's say it's the limit as x approaches infinity, where do you think the dominant term is? Do you think it's a quadratic function or an exponential function? So it's actually the exponential function. Exponential is going to grow faster than quadratic. So if the numerator wins, we think about plugging in positive infinity divided by a positive, right? So this would approach positive infinity because the exponential function won. So you're going to go through the rest of the questions up through 24. You're going to use this answer key to check your work, and then you're going to take the Google form 6-question quick kind of quiz, check for understanding. Not graded as a quiz. And then you're going to complete the next part of the directions.